Good evening, everyone. Thank you for joining our presentation today. Our topic is exploring Heron's formula. We will start in the order of the contents, and here is how we share the work. This project is designed for 8th grade students in mainland China, with a 14-minute lesson duration. Before dividing into Heron formula, students are expected to have solid understanding of base triangle concept, air formulas, the Pythagorean theorems, and some algebraic skills. Our course objectives are divided into 4 main areas. The first one is knowledge and skill. Students will understand Heron formula, which allows us to calculate the area of a triangle when all three sides lengths are known. They will enhance their problem-solving abilities, improve their mathematical expressions, and communication skill. The second one is process and methods. We encourage students to exploring and learning, where students will actively engage in discovering and applying the formula. They will connect this new knowledge with prior concept. The next one is attitudes and values. This course will make the cultivations of interest in mathematics, and the last is objectives for the integrations of the history. We aim to integrate the history of mathematics into the lesson, highlighting the contributions of Heron and Qin Jiushao, a Chinese mathematicians who independently discovered similar formulas. This will help students appreciate the cross-cultural development. Next, there will be a history of Heron formula presented by our group member.
The part 2 is about history of Heron's formula. Heron lived in ancient Greece during the Alexandrian period, a time of rapid growth in math and science. At that time, the city of Alexandria was the cultural and academic center of the Roman Empire and attracted many scholars. Heron's research was remarkably diverse. He was not only a mathematician, but also a magnesium physicist and a surveyor. His works covered many subjects, and he placed a great emphasis on the practical applications of mathematics, inventing numerous ingenious mechanical devices, such as word clocks, serving instruments, and cranes. This page is about the story of Heron's formula. Heron's formula was discovered while he was working on land surveying. At that time, people normally measured the area of a triangle by determining its base and height, then applying the formula half the product of the base and height. However, measuring the height was often challenging in practice, so Heron found that the area of a triangle could be calculated directly using only the lines of its three sides. There is the famous Heron's formula. First, we need to calculate the semi-perimeter, then put the semi-perimeter into this formula to get the triangle's area. Heron's formula first appeared in Heron's work, Book 1 of Metric, which was a summary of the mathematical knowledge known at that time. Then there is the proof process of Heron's formula. As shown in the figure, for any triangle, by applying the Pythagorean theorem, we can get equation 1 and equation 2. Next, substitute the value of each square from equation 1, we get equation 3. Next, put the equation 3 into equation 1, so we can express height by only using a, b, and c. Then use the half product of the base and height to calculate the area of a triangle. Finally, the Heron's formula is obtained by a step-by-step simplification. China's Southern Song Dynasty famous mathematician Qin Jiushao also found the formula for the three sides of a triangle to find the area. He called this method three sides area method. In his book, 数数九章, Volume 5, there is a question. If we translate this question into English, it is, there is a field with three sides. The small side is 13 miles long, and the middle side is 14 miles long, and the large side is 15 miles long. So how large is this field? This question is about finding the area of a triangle with the lines of its three sides known. And the method of calculation in 数数九章 can be written as the equation. It is like this. So we can see Jin-Jiushou's formula and Heron's formula are different in form, but by analyzing the conversion process between these two formulas, we can find that Heron's formula and Jin-Jiushou's formula are completely equivalent in nature. And although Jin-Jiushou's discovery came after Heron's, he made it independently. So these two formulas are discovered independently in different culture backgrounds. In addition, the conversion process between these two formulas will be used in the lesson design of Part 3.
In the Part 3, let me talk about the teaching process. In the first, let me introduce the instruction model in our lesson design. Our instruction model is the history and the pedagogy of the mathematics. We also call it HPM. Based on the series of the history of the mathematics and mathematics pedagogy, HPM teaching is not only concerned with the transmission of the mathematical knowledge, but also with the comprehension of the mathematical idea and methods, as well as the cultivation of the mathematical ways of thinking. The HPM model is no longer a simple illustration of the knowledge, but a better understanding of the natural and the connotation of the mathematical knowledge by the understanding of the history of mathematics. There are some steps of the implementation of the HPM model. First is theoretical of the conceptual framework building. Teachers need to know how the history of the mathematics can be integrated into the historical and conceptual framework of the mathematics education. For example, analyzing the development of the mathematical-related concepts in history provides a new perspective and approach for the modern teaching. And the second is design and implementation of the teaching, according to different teaching objectives and students' needs. Design and implementation diversified teaching to integrate history elements into the teaching process. Students interested in learning can be stimulated. And the last is assignment of the teaching effectiveness. The effectiveness of the HPM teaching model is assigned in terms of student understanding of the mathematical knowledge, change in their attitude toward the subject, and improvements the teacher's pedagogical approach. Why we use HPM model? There are some roles of the HPM. First is promoting understanding of the nature of the mathematics. It can help students and teachers to recognize that mathematics is constantly evolving and that interact across cultural and science field. For example, an understanding of the history of the mathematics enables one to see the evolutions of the mathematical knowledge over time. And second is to invitation pedagogical approach. HPM model can provide a new perspective and method for teaching and learning mathematics. Teachers can make use of historical mathematical problem, methods, and story to design more inspiring teaching and learning activity to stimulate student interest in learning and inspire of the exploration. And the third is supporting teachers' professional development. It helps teachers to enhance their mathematical knowledge and pedagogical skills. By studying the history of the mathematics, teachers can be better understanding the development of the mathematical concepts. And the last is promoting course curricular instruction. HPM emphasizes the link between the mathematics and the areas such as history, science, technology, and arts, contributing the course curriculum instruction. In the second part is the lesson design. My teammate will introduce this part.
The lesson design includes 6 parts. They are review and introduce new topic, historical context and significance, transfer between two formulas, application exercise, extension, and summary. In the beginning, we will show off 3 pictures like this and let students observe them. Then we will ask them how to find the area of these triangles. Most of students will answer using the formula S equals to 1 over 2 times base and height, since they learned it before. And some students may think about using the Pythagoras theorem to find the height. Then ask them to the second and the third question to introduce the topic. How to calculate the area without heights, but lengths of 3 thighs. More than 2,000 years ago, how ancient people calculate the area of a triangle. So we can show that in ancient times, the ancient Greek mathematician Heron proposed a formula that only needs to know the length of the 3 sides of a triangle. You can directly find the area. This formula is known as Heron's formula. In ancient China, the mathematician Qin Jiushao also proposed a similar formula called triclinic geometry, 三斜球基数. Today we will explore the origin of Heron's formula and understand its relationship with Qin Jiushao's formula. In the second part, we will introduce life and contribution of Heron and Qin Jiushao. They all discovered the formula respectively. And then we will guide students to think about the discovery process of Heron's formula. We will start with geometric intuition. Heron likely studied with special triangles, such as right triangles, to discover the relationship between area and side lengths. So let's look at the equation above. We all familiar with the formula S equals to 1 over 2 times AB, and we can also use C and A to represent the area S. Then, from the angle of algebraic derivation, Heron used Pythagoras theorem and area formulas to divide the area formula for a general triangle through algebraic manipulation. So finally, we can get this equation with a lot of algebraic manipulation. The last one in part 2 is a geometric proof. In his work Metric, Heron provided a geometric proof using the cycle of the triangle and the relationships between its side lengths to demonstrate the correctness of the formula. However, grade 8 students in junior high school haven't learned cycle before, so students can choose to learn about it after school. The third part of lesson design is transfer between the two formulas, Heron's formula and Qin Jiushao's formula. We will ask students that the two formulas look different, but they all can be used to find area of a triangle. So is there any relationship between them? Then we will guide students to prove the equivalence of Heron's formula and Qin Jiushao's formula through algebraic deformation. We can transfer Heron's formula into Qin Jiushao's formula. The process may be like that. And vice versa, the process may be like that.
After exploring the formula's historical origins and equivalence with Qin Jiushao's formula, it is crucial to understand how students will engage with Heron's formula in practical scenarios. Firstly, we provide some simple multiple-choice questions that will test students' fundamental understanding of the formula learned in previous sections. For example, which type of the triangle is Heron's formula applicable to? And what is the first step of using Heron's formula? These questions are designed to identify and correct any misconceptions about formula structure early in the learning process. After that, students can apply Heron's formula to tackle with some hands-on calculations in guided examples. Actually, this isn't merely a computational exercise to assess students' arithmetic skills. It's also an opportunity to reinforce the universality of Heron's formula across different triangle types. Then, we shift to a more complex application for students to work in small groups. We introduce a variation problem where students must calculate the area of a quadrilateral by dividing it into two triangles and applying Heron's formula twice. This exercise extends students' understanding of Heron's formula beyond isolated triangles to composite shapes. It embodies the HPM framework by connecting historical problem-solving methods, like those used in land survey, which inspired Heron's original work, to modern educational practices. Then, in step 5, we encourage students to have some extension thinking with Heron's formula. For example, which formula or method do they prefer using in different contexts? Maybe Heron's formula is convenient to calculate any type of triangle area. But when dealing with the triangle which has 3 irrational square root sides, compared with Heron's formula, Qin Zhoushao's formula is much easier and time-saving to use. Also, we pose some thought-provoking questions like, what limitations might exist when applying Heron's formula? Can this formula directly generalize to quadrilaterals or other polygons? Students can share their opinions with classmates and explore more relevant information after class if they are interested. This activity aligns with our goal of cultivating students a deep, flexible understanding of mathematics that extends beyond rote application. At the end of the class, students are expected to recap shortly on what they have learned in this lesson, understanding Heron's formula historical context, derivation, relevant application, while also thinking about its limitations and extensions.
In the part 4, let me talk about our teaching reflection. First is the advantage in our lesson design can deepen the understanding or the knowledge. By studying history, students can learn about the development of the Heron formula so that they can understand the mathematical knowledge does not exist in socialization, but involved in the history. The second is to stimulate the learning interest. Compare with the present Heron's formula directly to students. Integrating the history of the mathematics can show the diversity and the interest of the mathematics in different cultures. And the third is to enhance the cultural literacy. Students can experience the development of mathematics in different cultures. Also, we have some limitation. First is the constraints of our teaching time. In actual teaching, integrating the history of the mathematics requires more time to tell the historical stories, introduce the background knowledge, etc. For the derivation of the Heron's formula, root calculation on the abstract letter is difficult for the student and may also be the time-consuming. And second is a higher knowledge base for teachers. Teachers not only need to be proficient in their professional knowledge in mathematics, but also need to have a deep understanding of the history of the mathematics. And the last is the difficult in select historical material. When selecting historical material related to Heron's formula, teachers need to spend a lot of time to select them and make sure their currency. And that this is our reference. And thank you for listening.